Good.
Okay, good morning, class. This morning we're going to talk about AIRC 10005. And we're going to talk about Part B, or Module B, Pressure-Temperature Relationships. I'll just leave it at that. We mentioned the other day that one of the most important things that you'll do on a refrigeration or air conditioning system is you will measure the pressures of that system. And of course that's what your gauge manifold set is for. You'll use the gauge manifold set to attach to the system at your access valves, and there's another lesson on access valves that we'll go over. But for now we're going to start with the fundamentals of the pressure-temperature relationship for the vapor compression refrigeration system. One of the things that you need to understand is that everything involves pressure, and we'll go back a little further. When you control the pressure in your refrigeration system, you're going to control the temperature in each part of the system, and that's the premise on which the vapor compression refrigeration system works. When you control the pressure, you control the temperature. Now, we'll go back to a reference that I'm sure you're all familiar with, and that's atmospheric pressure. Atmospheric pressure at sea level at what, I don't remember exactly what the book says, like 70 degrees Fahrenheit or something like that, is like 14.696. Some people round that off to 15 psi. Sometimes some people round it off to 14.7. You can use either one of those. If you do any calculations using pressures and temperatures, or if you need to determine what absolute pressure is, it's best just to round it off to 15 psi. So that's the starting point, is atmospheric pressure. That's the pressure that, surrounds us. When we get up in the morning, we're surrounded by roughly 15 psi of pressure. Now, that pressure can change. If we go to Death Valley, it's going to be just a little more than 15 psi, because the atmosphere is, you're below sea level and the atmosphere is a little heavier. The 15 psi is the weight of the atmosphere on the surface of the earth. So that's a good reference. And also, if you go up to highs, if you go up on top of the Mount Everest, the pressure is going to be lower because there's not as much atmosphere up higher on the higher elevations. But in everything we talk about in this class is going to involve the air conditioning system some kind of way, or refrigeration systems. It's going to involve the pressure-temperature relationship. If you're dealing with pressures, if you're doing scientific equations dealing with pressures, it always asks you to determine absolute pressure. When we install our gauges on a unit, we're going to be reading gauge pressure. We got your low side pressure gauge and your high side pressure gauge. When we connect these gauges to a system and we read our pressures, we're reading what's known as gauge pressure. So then, excuse my sloppy writing. Or better known as PSIG, pounds per square inch gauge. And of course, pounds per square inch is more or less an American standard measure. You can get into pascals and other types of pressure measurements, but we're going to be measuring pounds per square inch. So PSIG is what you measure on your gauge. If for some reason you need to be able to determine absolute pressure, all you have to do is add atmospheric pressure. Let's say, for example, we install our gauge on a unit and we read 30 PSIG, and we want to express that as absolute pressure. All you have to do is add 15. And so our absolute pressure is going to be 45 PSIA. and that's how we determine absolute pressure. Getting back to what we were saying earlier, when you measure the pressures on a refrigeration system, you're going to be measuring gauge pressure. Most of the time you measure pressure on anything, you're going to be measuring gauge pressure. When would you need to know absolute pressure? Let's say, for example, you want to determine the compression ratio of a compressor. And the compression ratio, the formula for that is absolute discharge over absolute suction. And the way you determine this, you take your discharge pressure on the system, take your suction pressure using your gauges, and you add the 15 to each one of those, and that gives you absolute pressure, and then you just do the math. You divide the smaller number in the bottom into the larger number on the top, and that's going to give you your compression ratio. We're going to try to make these video lectures, about 10 minutes each, because usually that's the attention span most people have. So we're about to conclude this portion of the video lecture. But just keep in mind that when you're dealing with a refrigeration or air conditioning system, the pressures are paramount. Measuring pressures are paramount. We gave each one of you a pressure temperature chart. There's one thing I want you to remember about pressure. When it comes to refrigerants and refrigeration systems, air conditioning systems, at any given pressure, for any given refrigerant, you're going to have a corresponding temperature. That's one of the laws of physics, one of the gas laws. There's always a specific fixed pressure temperature correlation. Now when we get into some of the blends, some of the refrigerant blends, that's going to change a little bit because you have what's called temperature glide, and that's another lesson in itself. But most of the time you can look at your pressure temperature chart, and you can measure the pressure on that system, and you can look at that PT chart, and you can determine what temperature that refrigerant is inside the system based on that pressure. Is that making sense to anybody? Pressure-temperature relationship? I hope it is. We'll conclude this part of the lecture and the video lecture, and we'll continue our lessons on pressure-temperature relationships.